7.3, problems 5 and 6. Here's 5. What is the minimal sample size needed to be 95% confident for a 95% confidence interval to have a maximal margin of error of 0.1 in the following scenarios? Okay, so A, we have a preliminary estimate for P to be 0.19, and B says there's no estimate for P. We do have a formula for the sample size necessary for a proportion. It's a fraction, PQ, now those are the estimates for P and Q, times the critical Z value, that's what we're going to get from our confidence interval, squared over the error squared. So in part A, we are saying this preliminary estimate for P is 0.19, and we are running a 95% confidence interval. So at 95, let me get a little bit more room there. At 95%, now do you remember what this Z value is, that critical value of C? That critical value of Z at 95% is 1.96. Now you may remember these. If you were running this at 90%, at 98%, 99%, or just to recall these, this was 1.64 or 1.65. This one was 2.33, and then this one is 2.58. Those will come up from time to time. Now, P being 0.19 is going to give us that Q is 1 minus P, so that's going to be 1 minus 0.19, that's 0.81. Now, I think we have enough for our computation, right? Here's what we're going to have. N is equal to 0.19 times 0.81 times our 1.96 squared all over the error squared, and the error is at 0.1, so we're going to have 0.1 squared. And then we're always going to round up, right? It's a sample size, so we have to be sure to remember to round up. So I got the sample size N being 59.122 and so on. So I have to round up, so I'm going to say that the minimal sample size here is 60. So let's report that back up at the top where we're supposed to write it here. So this will be a 60. So part B tells us there is no preliminary estimate for P. So in part B, we will have to use P being 0.5, Q being 0.5, 1/2 and 1/2. Right, now let's put into our formula. So we will get N is equal to 0.5, 0.5, still the 1.96 squared, all over the 0.1 squared. Now I got N equaling 96.04, and if you round up, N is 97. All right, so let's report that back up here at the top, 97. And now you can see that if you have no information at all, you're going to have to sample 97 items. If you do have some preliminary information, say based on a recent past sampling, you only have to sample 60. Problem number 6. For this problem, carry at least 4 decimal digits after the decimal in your calculations. Answers may vary slightly due to rounding. Okay, so we want our calculations to always carry 4 decimals, but we're going to have the calculator do it, so it should not be a problem for us. In a marketing survey, a random sample of 986 supermarket super shoppers revealed that 280 always stock up on an item when they find that item at a real bargain price. Now, part A says, let P represent the proportion of all supermarket super shoppers who always stock up on an item when they find a real bargain. Find a point estimate for for P. All right, so a point estimate for P, how about this? This is going to be 6A. Oh, I totally missed that. 6A, P hat. All right, well, that's going to be R over N, and in our case, R is 280, and N is 986. So P hat is 0.283975 ... But what are we told? Just I kind of remember this. Carry at least 4 places after our decimal. All right, so 1, 2, 3, 4. You know, I think I'm going to raise this up 10. That'll make that a 4. So how about 2840? So let's go with our estimate of 0.2840. So I'll put that down here on the left, 0.2840. Now part B says we want to find a 95% confidence interval for the proportion. So on our calculators, here's where we're going to go. We're going to go to Stat. Then we're going to arrow over to Test. Now remember, it's not tests that we want. That's 1 through 6. We want to go all the way down to item A. All right, so scroll down to A. Now A says 1 proportion or 1 prop Z interval. We don't want a test, we want intervals. So you want 1 prop Z interval. So we'll select A. A is asking us for X. Now X is the R, that's the number that you observe. And for us it was 280, all right, so we're going to put in a 280. N is the 986. The confidence level is 95%, so put in 95 or 0.95 and calculate. Now my calculator shows 0.2558. Now it has a 3 after that, but I'm going on with just 4 decimals. 0.2558 and 0.3121. 0.3121. So I will report that over here on the left. The lower bound, the lower limit is 0.2558, 0.2558. The upper bound is 0.3121. So just what does this mean, right? We got this interval down here. So what does it mean? Well, I think it means we're 95% sure that we have captured that this interval includes the true proportion. All right, we've captured the true proportion. So what does it say up here? What are our choices? We're 5%? No, forget this 5%. What about this 95%? We're 95% confident that the true proportion of shoppers who stock up on the bargains falls within this interval. That sounds reasonable. What's the other one here? We're 95% confident that the true proportion of shoppers who stock up falls outside the interval. Well, that makes no sense. Let's go with the second one here. We'll go with this one. We're 95% confident that the true proportion is within our interval. And what is C? As a news writer, how would you report the survey results on a percentage of supermarket shoppers who stock up when they find, okay, how would we report this? Just report P prime, report the confidence interval, report the margin of error. You know, when you listen to the news, this is usually what you hear, right? It's this percent plus or minus some margin of error. So I think that's probably our best choice. Now there's one more part way down here at the bottom. It says this: what is the margin of error based on that 95% interval? Okay, so the margin of error, we can always get the margin of error by doing this. The margin of error, oh, let's just write E. Okay, I'm just going to write E. All right, so the margin of error is always, all right, it's going to be, say, the upper limit minus the lower limit divided by 2, right? It's always halfway between the upper and the lower limit. So for us, I'm just going to write it as this. It's going to be let me get the right number first, 0.3121 minus the lower limit 0.2558, and I'm going to divide that by 2. Now when I do that, I'm coming up with, I'll do it right up here, I'm coming up with 0.02815, and we always know there's rounding, so what does it say to round? Round to 3 decimal places. Okay, 3 decimals. So 1, 2, 3. How about just 0.028? So let's claim that 0.028.